So today's topic is about the motion. This is a very important topic as you will find variety of the questions from this topic and combined with other topics. The first part of the motion is about the kinematics in which we'll discuss the motion of an object without including the force. Like we'll ignore the force, we'll just include the motion. And the second it will be the dynamics. The second part of the motion will be the dynamics in which we include how the force can affect the motion. These are the learning objectives for topic 2.1, student taking Cambridge. These are the learning objectives. We'll go through each of them. And for EdExcel student, these are the learning objectives. Now, first we start with the definition of a distance and the displacement. So how we define the term distance? Distance is the total length covered between the 2 points. So how much length we covered to move from one point to another, we call that as a distance. Example, a person starts from A and he follow the track and he reach position B. So the total length which the person covered, that is called a distance. Example, say this was 10 meters. So we say the distance covered by the person from moving from A to B is 10 meters. So distance is actually the total length which we cover between the 2 points, irrespective of the direction. It can be in a straight line, it may be a curve, or it may be a zigzag, but the total length which we cover, we call that as a distance. But what about the displacement? Displacement is the shortest distance between the 2 points. And it is always in a straight line. So when we cover a shortest distance between the 2 points in a straight line from the start to the end, we call that as a displacement. Sometimes the distance and the displacement have the same value. Example, a person starts from A and he reach position B, he covered 3 meters. So because the person move in a straight line, in this case, if we say what is the distance traveled, the distance will be 3. What is the displacement? The displacement is also 3. So in a straight line, if object does not change the direction, the distance and the displacement have the same values. But what if a person changes the direction multiple times and we want to calculate the distance and displacement for that example? Like he changed the motion, moved perpendicular to the initial direction. So a person first moved 4 meters towards right, and then he traveled 3 meters towards north or upward. So if you want to find the distance, what will be the distance in this example? So distance is the total length which we covered from the start till the end. So what is the distance covered? First he covered 4 meters and then he covered 3 meters. So the total distance covered will be equals to 7 meters. But what about the displacement? Displacement is the shortest distance between the 2 points. So we always join the start to the end, irrespective of how it has moved. So when we join the shortest distance between the 2 points, this will be the displacement. How we can work out the displacement, the magnitude of the displacement, as you can see here, it is making a right angle triangle, like the displacement is the hypotenuse for us. So if this is a base and this is a perpendicular, so if we want to work out the displacement for an object which changes the motion, changes the direction, perpendicular, like first move towards one direction and then perpendicular to the initial direction. So we use the Pythagoras theorem. So in this case, it will be 4 square plus 3 square in a root. That will give us the displacement. So in a straight line, the distance and displacement are same. If an object changes the motion like perpendicular to the initial direction, to work out the distance, we just add the total length which the object covered. But for displacement, we use the Pythagoras theorem. What if we need a displacement for an object moving in a circular path? So there's an object starting from position A. This is the center. The distance from the center to the surface, that's a radius. Example, the radius is equals to 10 meters. So an object starts from A, move in a circular path and reach position A. So what is the distance covered by an object? So in a circular path, the distance is equals to the circumference. Because the distance, definition of the distance is the total length which an object cover when it moves from one point to another. So when we move in a circular path, the distance covered is equals to the circumference. So in this case, the distance will be equals to 2 pi r. But what about the displacement here? So what will the displacement? Because the start and the end is the same, so what will the displacement? The displacement will be 0. Because the starting point and the final point both are same, that's why the displacement is 0. So an object may cover a distance, but it may have a 0 displacement if the starting and the final positions are same. But if I say an object move from distance A to distance B, what is the distance covered? What will the distance? Moving from A to B. So for a circumference, it is 2 pi r. So semicircle, it will be half of the circumference, so it will be pi r. Yeah, 2 pi r divided by 2, so we can simply say it will be pi r. But what about the displacement? Displacement is the distance from the start till the end. So it starts from here and it reaches position B. So what will the displacement of this object? So displacement will be equals to the radius, a double of the radius or a diameter. So this is 10 meter. This is also 10 meter. So in that example, the displacement will be equals to 2 r. Okay. Is it clear? So in a half of the circle, the displacement will be equals to twice of the radius, or we can also say equals to diameter, where the distance will be equals to half of the circumference. Is it clear till this point? Anyone having a doubt or a question? But what about the quarter of the circle? So what about the quarter of the circle? Example, an object is at position A and it moved to position B. Say the radius is r. What is the distance traveled from moving from A to B? Yeah, a quarter of the circumference. So circumference 2 pi r divided by 4. So it will be pi r by 2. That will be the distance. But what about the displacement? What about the displacement? So displacement is actually a shortest distance between the 2 points. So when we draw an arrow for the displacement from A to B, that will be equal to the displacement. And this will also be radius. This is the displacement. So we will use a Pythagoras theorem again. So displacement will be equals to under root r square plus r square. So that will be equals to under root 2r square, or when you further simplify, under root 2r. That will be the displacement. Is it clear, this example? So you may have a complete circle and you have to work out the displacement and the distance, semicircle, or you may have a quarter of the circle. So when we talk about the distance here, the distance is the total length which we covered. So when we are moving from A to B, this is the length we covered. So that is the distance. And for a complete circle, the distance is 2 pi r. But because we complete the quarter of the circle, that's why we divide it by 4. That's why it is pi r by 2. But for the displacement, it's a distance, the shortest distance between the 2 points. So when we start from position A and reach position B in a straight line, that will be the displacement. So the radius distance from the center to A is R, distance from center to B is also R. So we use the Pythagoras theorem in that case as we need the hypotenuse. So we'll use the base square plus perpendicular square in a root. So it will be R square plus R square in a root, which result in under root 2 R. So this is the difference between a distance and a displacement. The next is the difference between the speed and the velocity. So how speed and velocity are different from each other, or what is the difference between them? And one more thing, like distance is a scalar quantity, like it does not, we don't specify a direction, but displacement is a vector, it has a specific direction. So the difference between the speed and the velocity, speed, it is distance covered in a unit time. And velocity, it is displacement in unit time. In IGCSE, you used to write the same definition for distance and you used to write the same definition for the speed and the velocity. Like when we use the term calculate the velocity, you was also saying like distance in a unit time. Because the reason for that, in IGCSE, you was taking a simplified motion that always the object was moving in a straight line. But now what will happen? You will have the scenarios in which the object does not move in a straight line. The object will change the directions. So if I say an object, so the object may have a same speed and velocity, the magnitude might be same if it move in a straight line. But if it changes the direction, the magnitude of the speed and the velocity will be different. So say an object is there moving at its like covers first 10 meters from A to B, and then it cover 5 meters from B to C. Well, if you want to work out, and the duration, like the journey lasts example for 4 seconds. So what is the speed here? If you want to calculate the speed, so speed is distance divided by time. So distance is the total length which we cover. So at first 10 meters, then 15 meters, so 5 meters. So the total will be 15 meters and divided by 4 seconds. So 15 divided by 4, that is equals to 3.75 meters per second. That's the speed of this object. And we did not specify direction. Like this object covered 3.75 meters every second. But what about the displacement? To work out the displacement, you have to draw a straight line from start till the end. Always from the start to the end, that will be the straight line. So in this case, this will be the displacement. So if we need the velocity is displacement in a unit time. So what about the displacement? 10 meter and 5 meter. But because the direction has changed, like it changes the direction, move perpendicular to the original. So we have to use a Pythagoras theorem. So that will be equals to, the displacement will be equals to under root 10 square plus 5 square. So what's the answer? 100 plus 25 in a root. Under root 125.
11.18.
So 11.18 meters is the displacement. And what about the time? The time is the same, 4 seconds to reach that place. So 11.18 divided by 4. What's the final answer? So it will be
2.795.
So it's 2.79 meters per second. That is the magnitude of the velocity. So you can clearly see the magnitude of the speed and the velocities are different. And what about the direction? So if you want to work out the direction, so what we can use a trigonometric ratio. Like we know this is 2.79, we know this is 10 and 5. So we can use, if we want direction, we can work out the direction from the north, south, east, and west. So we can work out the either direction from the north or east. Or if we take this angle, we'll take the direction. This is north, south, east, and west. So we can work out the direction from south or from west. Is it clear, the difference between the speed and the velocity and how you can work out the direction? Anyone having a doubt or a question till this point?
No, sir, no doubt.
What about others? Ammar, Aisha, Eamon, Fabia, Hafsa, you just mentioned Imad. Shahir. Working out the direction of the velocity, look, the direction of the velocity and the displacements are always same, okay? So if I work out the direction, like let's say this example. If I work out the direction of the displacement, the direction of the velocity will also be same. So simply, even though this graph is like this figure is representing a displacement, so I have 10 meters here and I have 5 meters here. And this one, even though it's a displacement, but the rate, because the direction of the displacement and the velocity is same. So what actually I'm working out the direction of the displacement, and that will be same as the direction of the velocity. So this, if I take the direction, like example, because the displacement was 11.18, so when I substitute, if I'm taking this right triangle in terms of the displacement, so this value was 10, this is 5, so how much displacement I should take? Because if I'm taking a displacement, so I should take is 11.18, because that's a displacement. Now we take an angle theta here, so if we take an angle theta, this will be the base for us. This one is a perpendicular and this one is a hypotenuse. So if I use a tangent theta, which is perpendicular divided by base, the perpendicular is 5 and the base is 10. So tan inverse 5 by 10 means tan inverse 0.5. What's the answer for tan inverse 0.5? $26.6. So 26.6 degrees. So means I can say when I mention a direction, so this is 26.6 degrees, this angle. So I can say 26.6 degrees. The direction is 26.6 degrees from north. Or I can say, from east, not north. So 26.6 degrees from the east, because this is the east, or I can say north of east. Because when I move toward the north from the east, this will be 26.6. Or I can measure this angle like 90 minus 26.6. So I can say that angle east of north. So this will be 63.4. So I can say it is 63.4 from north, or I can say east of north. That's how we work out the direction of the velocity. So we work out the direction of the displacement, and then the direction of a displacement is same as the direction of the velocity. Is it clear, this example?
Yes.
The next is acceleration. Acceleration is refers to the change in the velocity. Whenever we say it's a rate of change in velocity, like how much the velocity changes every second, we call that as acceleration. So if an object is, example, moving at an initial velocity of u, after some time it has a velocity v. So in a starting velocity, the initial velocity is called u, and the final velocity is called v, and it takes time t. So what is the acceleration? Acceleration is the rate of change in velocity, so the final minus initial divided by time. If an object does not change the direction, Then we just subtract the magnitude. Like example, this one is this one is u. Say the u was 20 meters per second and the v was 30 meters per second and it took 4 seconds. So what is the acceleration? In this case, the acceleration as the direction does not change. So 30 minus 20 divided by 4. So it will be 10 divided by 4. 10 divided by 4, it will be 2.5. And the unit of acceleration is meter per second square. Okay. But what if the direction changes? If an object is there moving at an initial speed of 20 meters per second, that is u, and it changes the direction, it changes the velocity, and as the direction changes, the magnitude of velocity example changes to 30 meters per second. And we want the acceleration in 4 seconds. The same question, but we need the acceleration in 4 seconds. How to work out the acceleration in this case? Because acceleration is a change in the velocity divided by time. Means in terms of the vector v minus u. So this is vector u and this is vector v. I need v minus u. So if I need v minus u, what I will do? I will draw the vector v first. So first I will draw vector v, which is downward. I will draw 30 meters per second. Then I will draw vector negative u. So u is towards the right, negative u is towards. So this will be negative u. The magnitude is 20. Then what about the change in the velocity? So this will be equals to v minus u. So this is example, this was v. And this was an example representing the u, and this is representing v minus u. And how to calculate the magnitude of the v minus u? So if I want to calculate the magnitude of the v minus u, I will use a Pythagoras theorem because it is making a right angle triangle. So in that case, the v minus u will be 30 square plus 20 square in a root, the magnitude of v minus u. Okay. And the time, it's 4. So it will be v minus u divided by 4. So 30 square plus 20 square in a root. What's the answer for that? 30 square plus 20 square in a root. So that is 50 divided by 4. So 50 divided by 4, we'll get 12.5 meters per second square. So that will be the acceleration of this object. Is it clear? So if the direction does not change, you just take the magnitudes. But if the direction changes, to work out the v minus u, you have to do a vector subtraction rule, like follow the vector subtraction rule, and then you will simplify. Yeah, we use a Pythagoras rule here to work out the magnitude of v minus u. So first we drew vector v, then we drew vector negative u. So the v minus u from the tail of the first to the head of the last, that was v minus u. And this v minus u is a hypotenuse. That's why we use a Pythagoras theorem. So the magnitude, this was 30. And this was, even if you substitute minus 20, but it is square. So it won't make difference. We'll get the same result. So 30 square plus 20 square in a root. What's the answer for this?
Sir, it's 36.05.
Okay. So this is 36.05. Then 36.05 divided by 4?
9.
9. So it will be 9 meters per second.
0.01.
So 9.01 meters per second square. So in a vector, you have to subtract. Like you have to work out the resultant in this way. The only difference between a v plus u and a v minus u is that direction will be different. Direction of a v plus u and v minus u will be different, but we work out in the same manner. But acceleration, definition of acceleration is a rate of change in velocity. So in terms of vector, you have to work out in this manner, okay? Another example, say an object is traveling at 3 meters per second, and the initial velocity is 3, and it changes the direction and it moves vertically 3 meters per second. Is this object accelerating? Yes or no? Is this object accelerating? We can use a chat. Yes or no? Yes. Is this object accelerating? An object first move at a speed of 3 meters per second. Is this object accelerating? I want participation from everyone. Yes, Mubashir. Amen. The correct answer, this object is accelerating. How this object is accelerating even though the magnitude does not change? But the term acceleration is a vector quantity. It's not only about the magnitude, it also depends on the direction. Even though the magnitude does not change. Here, the magnitude was 3 meters per second. Here also magnitude is 3. Because the direction has changed, that's why this object is accelerating. So, and what will be the acceleration of this object? How we can work out the acceleration? Because acceleration is v minus u over t. Why this object is accelerating? Because the term acceleration means rate of change in velocity. And velocity is the vector quantity. If the direction changes, the object is also accelerating. So how we can work out the acceleration of this object? So first we need a v minus u. So first we draw v, like v is 3 meters per second. Then we draw negative u. This is u towards right, so negative u will be towards the left hand side. So the acceleration of this object is due to change in direction, not due to change in magnitude. So this will be negative u, this was v. So if we need the resultant, like we need a v minus u from tail of the first to the head of the last, when we join them, that will be equals to v minus u. And again, this we'll use a Pythagoras theorem. So if we want to draw the v minus u, the v is upward. So we draw the upward arrow for v, and then we drew the upward arrow for the v, which is 3 meters per second. And then we draw negative u, which is u is towards the right hand side, so negative u is towards the left hand side. So that will be negative u, which is minus 3 meters per second. What about the resultant? For v minus u, from tail of the first to the head of the last, when we join, we get the resultant for v minus u. And what is the magnitude of the v minus u? The magnitude of the v minus u will be, it will be minus 3 square plus 3 square in a root. So minus 3 square is actually 9. 3 square is also 9. So it will be under root 18 or root 18. What is the answer for root 18? Under root 18. So that is equals to 4.2 meters per second. So 4.24 meters per second. And that is the change in the velocity. And if I say an object changes a velocity in 2 seconds, so we need an acceleration, it will be v minus u over t. So it will be 4.24 divided by 2. So it will be 2.12 meters per second square. That will be the acceleration of this object. So the acceleration is not 0 here. Why I did not take the negative value in the last example? Actually, it does not make difference, as here we have to do a square. Like when we are finding v minus u, So it was under root u square plus v square when it was perpendicular. So even if I substitute the value of a negative u3 or minus 3 does not make difference to the magnitude. That's why I did not include that in the last example. Reason just why I included in this one just to make sure that you can include or you may not include. It won't make difference to the final answer. Yeah, the time is 2 seconds. Is it clear, this example about the acceleration? So if the object changes the direction, we
Yeah.
also call that as it is accelerating. What about an object move in a circular path? Say an object is there moving in a circular path. It has a speed or a velocity of 3 meters per second here, and it has a velocity of 3 meters per second here. Is this object accelerating? Yes, Amant, we took under root plus minus. That's right. But if I use the term magnitude, so I don't have to include a plus minus. That like whenever you take a root, two possible roots are there, negative and the positive. But when we say about the magnitude, that's why I was just focusing on the number. My question is there a change in speed for this object? Yes or no? Is the speed changes? Is there a change in speed? Change in speed. So there is no change in speed. Why there is no change in speed? Because the speed is a scalar quantity. It does not depend on the direction. So if you change the direction, the magnitude does not change. Direction has changed, but the speed does not depend on the direction. That's why we say there is no change in speed. But is there a change in velocity? Is there a change in velocity? Why there is no change in speed? Because the magnitude was 3 here and the magnitude is 3. But is there a change in velocity? Yes. Why we say a velocity has changed? Because why we say a velocity has changed? Because the direction has changed. So irrespective how the direction changes, if a slight change in direction, it means there is a change in velocity. So this object has changes the velocity because the direction has changed. Is this object accelerating? Is this object accelerating? So again, the answer is yes, it is accelerating. So the concept of acceleration is a change in the velocity. And the concept of the velocity, if the direction change, the object always changes the velocity. Another example. Say you drop a ball and it hits the ground and bounce back. So when you drop the ball, it hits the ground at a speed of 10 meters per second and it bounces back with a speed of 8 meters per second. An example, it took 4 seconds to change the speed from 10 to 8. Now, is there a change in speed? Is there a change in speed here? Yes or no? Yes, there is a change in speed. Because the magnitude has changed, it changes from 10 to 8. So yes, there is a change in speed. Is there a change in velocity? Is there a change in velocity? Yes, there is a change in velocity. In this time, the change in velocity because of two things. One is because of the direction and one is because of magnitude. Because the magnitude and the direction both has changed, that's why it's a change in velocity. Is this object accelerating? Like, is there a change in velocity? So answer is yes. Now, if I say, what is the change in velocity here? How to work out the change in velocity if the direction is exactly opposite? So we know velocity is a vector quantity. So how to represent a vector quantities? So it's up to you. Any one of the direction you can consider as positive, the other will be negative. Example, if all the upward direction I consider as positive, so all the downward direction I'll consider as negative. So this object was moving, like initial velocity was 10. So I will not say 10, it is negative 10. Why? Because the initial velocity is downward. And the final velocity, it moves upward. So final velocity, I'll say it's not 8. I'll say it is positive 8 because it is moving upward. Now, what is the change in the velocity? The change in velocity is final minus initial. So the final is 8 minus, and the initial is negative 10. So when I simplify, so the change in the velocity will be 8 plus 10. So in that case, the change in velocity will be 18 meters per second. To work out the expression, the change in velocity divided by time. So simple way, remember, whenever object changes a direction and you need the change in velocity, you simply add them to get the change. But whenever object does not change the velocity, change the direction, to work out the change in velocity, you will subtract. Is it clear, this example about the change in velocity?
Yes, sir.
What about the change in speed? What is the change in speed here? So speed is a scalar quantity. We don't consider a direction. Okay. So when we don't consider a direction and we just subtract the number, so this will be 10 minus 8. So 10 minus 8, that's equal to 2 meters per second. Why I choose 10 first and why not 8? Because if I do 8 minus 10, it will be negative 2. But for the scalar quantities, direction does not matter. That's why for a scalar quantities, when we find the difference, we always use a greater value minus a smaller value. Like if I say the temperature 1 was 30 degrees and the temperature 2 was 50 degrees. What is the change in temperature? You will say 50 minus 30, so the temperature change is 20. But if I say the temperature change was 100, like the initial temperature 100 and the final temperature 20, and I ask what is the temperature change, you will do 100 minus 20, which is 80. So whenever for the scalar quantities, we work out the change, we don't bother about the which is initial and which is final. We work out greater minus smaller, as the difference, positive and the negative difference in a scalar does not affect. So this is about the speed, velocity, acceleration. Our next topic is about the equations of the motion and the derivation of the equations of the motion. So I'll share another link now. Join from the link and we'll complete that topic today.